Go ahead.
Okay, so we're gonna head on over. Oop, I meant to do that. I totally meant to accidentally click on my Firefox button. All right, so we're going to continue to VP 100 strings. And this, I gotta tell you, is the hardest part of Python. Once you get over strings, the rest of Python is a piece of cake. So as we mentioned in the previous example, we're using something called Python 3. So why are we using Python 3 and not Python 2 or Python 1? Well, Python 2 was popular for a very long time. However, a lot of people, especially our international friends, complained about the strings. A lot of programming languages like C and Java and Pascal would store strings as a series of 8-bit characters, essentially ASCII characters for people that know what ASCII is. And that is fine if you speak the Latin alphabet. However, let's say you have a lot more characters in your alphabet. Let's say that you are in East Asia, and let's say you're in Japan in particular. And not only do you have to deal with the Latin alphabet, you have to deal with kanji, you have to deal with hiragana and katakana. Well, that's way more than 255 characters that you could potentially have space for within the ASCII byte context, right? So there was a push to make the strings in Python Unicode. So that means that you can no longer depend that a single character in a Python string is 1 byte. So now Python has two essentially types of strings. You have the regular strings that are called strings, and you have bytes arrays, which are just a series of bytes. And you can think of those as kind of old school strings, whereas the things that we call strings in Python are actually Unicode. And to go between them, we're going to be decoding and encoding strings. And once you get your head around that, the rest of Python is easy. So I'm going to spend a little extra time going over this section. And then once we're done with this section, the rest of the sections are going to be faster to go over. So let's look at a simple Python greeting. Here we have a little Python program with a greeting. Let me go back into our nano editor. So we'll say nano strings 1.py. We're going to paste in our hello world program here. So here we have a greeting called hello world. We're going to print it out. And now we're going to look at substrings. So this is how substrings work in Python. You have brackets here, and if you've done programming before, you'll know that these look very similar to arrays, or in this case in Python, lists. So in Python, arrays are called lists for no reason whatsoever, other than that's what they're called in Python. We could have called them arrays, but we don't. If you're looking for substrings, you have a number, a colon, and a number. And so the first number denotes the first character, and the second number denotes the last character. So in this case, we're going to be looking at the greeting starting at the character 0 until the third character. Then we will look at the greeting from the third character until the sixth character. And then we will look at the entire greeting again, and we'll see how that works. All right, so we'll exit. Do you want to save the modified buffer? Push Y for yes, enter. Python 3 strings 1.py. Let's see what happens. So let's look back at, actually, you know what? Let's look back at the code this way. So we'll do nano strings. I'm in the wrong directory. cd py examples. Nano strings 1.py. So I'm back. So at the bottom of the screen, here's some of the code that we were running. And at the top of the screen, you can see the output. So at the first line, hello world, this is that print greeting thing we saw earlier. Then we see start, and then the first character, which starts at 0. So most arrays and lists in modern languages start at 0, not 1. And we go until the third character. So we print the 0th character, the first character, and the second character. Then we print, in the middle, we print the third character in hello world, the fourth character, and the fifth character, which is an L, an O, and a comma. And here we print the end by using a -3. So we're negative, we rolled over essentially. So -1 would have been the exclamation point, -2 would be the D, and -3 would be the L. So we're getting the end of the string by 3 characters. And notice there's no number at the end here. So if you omit a number from any side of this colon, that usually means if it's on the left side, it means from the beginning, or if it's on the right side, it means to the end of the string. So if you want to print from the, let's say, 5th, from the 6th character onward, you would say greet 6 colon and then no number after that. Likewise, if you want to print until the 6th character, from the 0th to the 6th, that's how you do it, :6, which is equivalent to the same statement as 0:6. So that's how you do substrings. And here we have a find statement. So Python is heavily object-oriented, and each string has several functions associated with it. One is find. Find will give us the position of a character in a string, or at least the first occurrence of that character within a string. So A is the index, meaning the number of characters in the string before we get to the first comma character. So in this case, we're looking at hello, comma, world. So in this case, A would be 0, 1, 2, 3, 4, 5. So A would be 5, because that's the position of the comma character. And portion before comma. Okay, so we are then printing all the characters before the comma. I know it's a lot to take in. Like I said, strings are the hardest part of Python. Once you get strings, the rest is easy. Save modify buffer, sure, let's do that. Now let's move on to the next example. Actually, we have some flags here. Connect to ad.samsclass.info on port 10102, send the string goodbye. And when we do, we'll get a flag. So let's do that one together. So here we have a socket program. I hope most of you know what a socket is already. If you don't know what a socket is basically the purest form of TCP. If you're trying to do a TCP program and you just want to connect a TCP port to another TCP port, we use sockets. And in this case, we're importing the socket library to connect to some raw TCP ports on Sam's server. So let's open up our famous nano editor for Py example2.py. And actually, let's go sock example.py. I think that makes more sense. Sock example.py. And we'll paste in that code that we got from the website here. So import socket all the way to s.close. And let's go over this program line by line. First, we start off with import socket. So we're telling Python, we're using the socket library. Get ready. Here we create our socket item. So we're creating a socket object to use, essentially. And then we're going to connect to ad.samsclass.info on, let's see, we might have to change this. We have to connect to port, I can't scroll for some reason, 10102. So let's change that in our code, because we're gonna have to change that anyway. So we're connecting to ad.samsclass.info on 10102 port. And then we're going to print what the server sends us. And then we have to send the server a string. We are going to send the string goodbye. So let's do that. So instead of hello from Python, we'll say goodbye. And then we'll read from what the server sends us again, and then close the socket. And let's see what happens. So let's run this Python 3 sock example.py. Let's see if we get a flag.
It's it's frozen right now. I'm working on it.
Oh, excellent. So if you are getting connection refused on some of these projects, it is entirely possible that the server is host. What happens is we can essentially run a slow LoRa attack on Sam's server, which is usually unintentional. what happens is we have a program here that opens a socket. And at the end, we're supposed to close that socket. So that's what this close command here does. However, if we keep too many sockets open, the server can't open any more sockets, and we essentially denial of service SAM server. And that's what happened. However, when SAM gets this...
112 works.
112. Okay, so there's some backup. Right, so there's some backup. We are aware of this, and so there are some backup ports, and they're listed on the page. If you look down here in troubleshooting, you'll see here that there's some challenge 1 goodbye ports. So we'll try 101.12, which is apparently up by Sam's word, which I trust inherently. So we'll, instead of connecting to 101.02, we'll connect to 101.12, Control X, Y, enter, Python 3, sock example.py, correct. Aha, we have our first flag. I encourage you to do this yourself, or you can look at my screen and get some free points for Violent Python 100.1. So let's clear this off. There we go. And let's go on to see what's next. So we figured out how to send a string to the server, get something back. Next, we're going to connect to the server and then do something with the data we get back. So we're going to find, the server's going to send us a number. We're going to have to use substrings to isolate that number and add 1 to it. And the one thing you have to know about this flag, or about getting this flag, is there is a difference between the way Python treats strings and the way it treats numbers or integers. So when we get a reply from the server, it's going to be in a string. And to convert between a string and a number, we use the int function and the str function to go back to a string. So let's look at that for a second. So how to convert between a Python string to an int? Yep, we use int. And if you want to go to an int to a string, you use this function right here. So definitely check out the help on that one if you're having any trouble. Let's go on to loops. If you are familiar with programming, loops in Python are very similar to other languages. The only thing about Python that is a trap for new players is that it depends entirely on indentation. If you use C or Java, you know that loops go inside curly brackets. And Java does not do this. Java expects either spaces or tabs to figure out where the loop begins and ends. And this is usually fine if you're working by yourself. When you start working with other programmers who, let's say you prefer tabs and the other programmer prefers spaces, they'll download your code, maybe add a new line, but they'll accidentally use spaces instead of tabs. And Python will have a hissy fit because it doesn't know what to do if it doesn't see the same type of indentation each line. So let's practice. We're going to copy this loop here that's on the page. We're going to go into nanopyloop.py and paste it in. So what's happening here? So we have a for loop here, and I'm assuming, yeah, Elizabeth says spaces instead of tabs. Blasphemy. Yes, I agree. So for I in range 3, what's going on? Python uses the range function to create a list of items ranging from 0, 1, and 2. So I is going to go 0, 1, and 2. And then we're going to iterate through a string. So each character in a string. So let's see how that works. Control X, save, Y, enter, Python 3, pyloops.py. There we go. So like I said, we use the range function to create an integer that goes up by 1 every loop. So we go 0, 1, 2. And then we use the same, we use a for loop with a string to go through each character 1 by 1. So here we have to use those. We're going to combine what we learned in VP 100.2 to find the flag 100.3, where we will have to add and subtract based on what the server sends us. So what we'll end up doing is we will send the server will send us a message saying, you got to subtract these numbers or you have to add these numbers. So we are going to have to figure out what the first word is. Either it's going to be subtract or add. We're going to have to isolate two numbers, do what the server says, and then send those numbers back to the server. This is actually kind of a hard project. It took me at least 15 minutes last time to do it with the students. So ASCII encoding. Like I said, so in C and other programming languages in the past, strings could have essentially be thought of as an array of 8-bit bytes. And you would store strings usually as a type of ASCII. So ASCII is I'm not gonna say format, it's a standard. That's the word I'm looking for, it's a standard. It defines a number with a letter. So hex 41, for example, is the letter capital A. And you can, of course, store 255 different characters, but in practice, usually the characters, the first 20 or so characters are control characters. And then the characters after that are usually what you would think of as the standard English alphabet or Latin alphabet, with a few extra exclamation points and commas, dashes, etc. thrown in. And then above 128, you have some special characters for creating boxes and stuff like that. But Python uses Unicode. So we could have things like hamburgers and smiley faces in our strings. Our strings can be up to 32 bits long per character. And if you're using UTF-8, not every character is going to have the same amount of bytes. So let's look at ASCII encoding. So let's open up Python 3. We're going to open up our interactive shell and type this in. So we are making a string called A, and these \x's, those are called escape characters. So we are going to have hex 41, hex 42, and hex FF. And if we were to print A, let's see what happens. We get an A, B, and a Y with some kind of umlaut or something above it. And we can, of course, look at each character one by one. So A0 is 1, and the last character is Y with an umlaut. Now, if we want to encode it, we can encode this as ASCII. So let's try that. Let's do B equals A dot encode. And let's print B. See what that looks like. Oh, it looks different. We have A, B, and some weird characters at the end here. That's because we encoded A as UTF-8. And this is what our string looks like in UTF-8. So we can play around with some Unicode. There are some examples here about the /u.encode.hex and whatnot, but I'm going to show you something fun. So if we go here and we search for smiley face emoji Unicode, we should be able to, hey, here we go. Oh, no, that's actually not what we want. We want, oh yeah, Emojipedia maybe. And we want the Unicode. We want the Unicode code for smiling emoji. Here we go. No? Here we go. Emoji. There we go. That should have it. Unicode. It's going to be on here somewhere. Big Indian. Indian, no. UTF. Okay. No. Here we go. We're looking for the UTF-32 hex. There we go. C syntax, we're gonna take this. This is what we're looking for, the UTF-32 hex C syntax. We're gonna copy that value here, which is 0000E414. We're gonna go into Python and say A equals \U, that big old value, and we'll print A, and my console does not support happy faces. I'm so sad. That did not go as well. Maybe we can do it from the web. Remember there's that web example from the last time. The web font might support it. Right, here we go. A equals, we need to use our escape, our Unicode escape, so capital \U, and then print A. Let's see what happens. Oh, we got nothing. Oh well. Maybe they're wrong. Maybe that's not the correct code. Oh, here we go. Let's try. No, that was what we had. Huh. That should have worked. I don't know what's going on. But let's try another Unicode character that's more common. Let's try to find Unicode first.
I think you had it. You just needed UTF-8, which was another choice there. It's 3 bytes.
It should work with the UTF.
Yeah, they're not all the same. I think it's
Yeah.
So Unicode can be very confusing.
Yeah.
No. Let's go to unicode.org, the full emoji list. No, is that going to work?
Yeah. Yep.
Try that one. See if that works. One of these will work. Nope. We need to find, we'll try to find the UTF. Oh, here we go. Because usually I look for the little endian UTF-32 Unicode, which is usually what works in Python, but we'll try UTF-8. UTF-8, character count, no. Here we go. Let's try, we'll need the hex byte, so it's gonna be EE9094. Let's go back to our Python 3 here. Let's run that. Nada. Yeah, like I said, I think it's usually the UTF-32 big endian that it works with. Yeah, that's too long. Nope. And the reason, by the way, the reason why I am going to the list here is because the examples even on Sam's site here was not working with Unicode. So I have no idea what's going on right now.
That was intentional. Some of them are not supposed to work. Yeah.
So this one should work though, right?
Yeah, scroll down and you'll see the screenshot, which one works. There.
Yeah.
Yeah, some of them work, but some of them are intended not to work. They show that only certain combinations of Unicode are accepted.
Oh, it is working. There we go. Yeah, no, I'm certain that the Unicode I was supplying was correct for the happy face, but it was not rendering correct. It looked like there were some glyph issues with the rendering engine. Not that, yeah, anyway. That's how Unicode works. You would look up the UTF-32 big endian syntax. Let me So UTF-8, UTF-32. You would grab this data, UTF-32 hex, yeah, E440, yeah. You would grab this data here, and that's how you get the correct Unicode value. So instead of using emojis, I'm going to try one more thing that should be a little easier on our font. Let's try to find Greek Phi Unicode. That should definitely be able to render in any decent font. Here we go, Unicode character Phi. UTF-32 encoding, here we go. We're going to copy this. We're going to go over to our Python. We're going to set it to our value we found. And A. There we go, there's our Phi. So like I said, it was a glyph issue. It was not anything to do with me not knowing what the value was. It just wasn't rendering. And that's usually what this character means in the console. It doesn't know what's going on. So anyway, that's Unicode. It takes a while to wrap your head around it. So we have some questions about Unicode at the bottom of the page. We're going to try to find the Sigma character. So you have to do some Googling for Unicode and find the correct Unicode value to print a Sigma character in Python. And like I said, you're going to look for the UTF-32 value. And then we're going to find the 8th character Unicode to print out a hamburger. And that should be, let's see, Unicode hamburger. Aha, here we go. Let's find UTF-32. And this should be it. It might not, like I said, we were having some glyph rendering issues earlier. So I want to see if this will actually render in Kali by default. Oh, there we go. We got a hamburger. Okay. So you may or may not have an answer to one of the questions there. Like I said, this is the hardest part of Python. I spent the most amount of time on it because it is tough to wrap your head around the strings and how they work in Python. But the rest of this will go much more quickly.